All right, so what we're going to talk about today is something called the unit circle, which is the foundation for a lot of trigonometry and pre-cal. It's super duper important and it has to be memorized. So this is just sort of the what is it and how does it or why does it look like it does. And then future videos you can learn how to memorize it easier and how to use it with trigonometry together, okay? So first of all, what is the unit circle, or why is it called the unit circle? Well, it's a circle with a radius of 1 unit. That's pretty much all it is. It just means, hey, it's a circle on the coordinate plane. Notice it's centered at the origin, and it has a radius of 1 unit. And that's all that means. So if it has a radius of 1 unit, that just means that I'm here, and if I were to go over to, say, this point on the graph, well, that would be the point 1, 0. If I were to go up 1, it would be the point 0, 1. So that's kind of how that works, okay? Now, what you're going to have to do on the unit circle is you're going to have to know the angles, and you're going to have to know specific coordinates that are along the outside of the circle. So let's just talk about angles first, okay? So we need to know the angles. Now, going around a circle, you may remember from geometry, there are 360 degrees in a circle. So you just need to know, where do you start measuring and where do you stop? Well, on the unit circle, and pretty much in this class the whole year, we are going to start measuring in the east. So I'm going to call that 0 degrees. That's how we're going to measure, and we're actually going to go counterclockwise, okay? So in order to get to 90 degrees, you don't want to go down here, you want to go up here to this 90 degrees. And you just count around that way. So if there's my first 90, here's my next 90, here's my next 90. Now if you make it all the way back around, how far have you gone? Well, you've gone 360 degrees. So you could call this 0 degrees because you're starting there, but some people also might call it 360 degrees because they are stopping there, and that's perfectly fine. So we need to know angles, and you're going to have to memorize, not 360 different angles and spots on the circle, but we're going to ask you guys to make sure that you can memorize increments of 30 degrees and 45 degrees all the way around the circle. I'll explain why those are so important later, but that's pretty much what you're going to do. You're just going to start counting by 30s. So 30 degrees would be something like maybe right there. That looks to be about 30. And 45 would be halfway between here and here. And then 60 would be, about right there. So we're kind of eyeballing it, but these three would sort of be in the middle, 30, 45, 60, and you could keep counting all the way around the circle if you like. I'm just going to focus on quadrant 1 right now, but you could do that, of course. Okay, the other thing you're going to have to be able to do is measure the angles not only in degrees, but also be able to do the angles in radians as well. Now, hopefully you've already learned what a radian is, and you've learned how to convert. As a refresher, to convert, if you take your degree and you multiply that degree by pi over 180, then you will get your radians, okay? So this is a formula you should have talked about at some point. So that's what I'm going to do. I'm going to go to these 1, 2, 3, 4. I'm going to go to these 5 and run this formula real quick and then see what the radian would be, okay? So my degree is, let's start with 0. Well, 0 is going to be easy. 0 times anything is 0. So the radian here would be 0. I'll put rads behind it, 0 radians, okay? 30, I would do 30 times pi over 180, which is 30 pi over 180. The zeros will cancel there. We'll divide out a 10, and then 3 over 18 is 1 over 6. So this becomes pi over 6 radians. So now I'll do my 45. So that'll just be 45 times pi over 180. And then I need to reduce this. 45 goes into 180 evenly, and actually that will reduce to pi over 4. If you don't believe me, start dividing it out. It'll happen, okay? And now we'll do 60, so 60 times pi over 180. Once again, divide out a 10, 6 over 18, that's 1/3, so pi over 3. And our last one is up top. It's 90 degrees. Well, 90 and 180 definitely go into each other evenly, and that's going to turn into a pi over 2 right up here. So these radians you are going to be responsible for memorizing. And it's very important to just suck it up and go ahead and memorize these 4, because these 4 will guide you through to the rest of the circle. That's in a future video if you want to see it, okay? But these are super important. So we got our degrees, we got our radians, and now I told you we'd be responsible for finding the coordinates on the circle as well. So in order to do that, I need to zoom in here. Okay. I'm going to zoom in because let's say we wanted this coordinate. So in other words, I need to get to this point. So I need to know what is my x and what is my y. I mean, that's how you get to a point, right? You go over x and up y. Well, notice the shape of what I've just drawn. If I were to straighten this out, what does it look like to you? Well, to me, it looks like a big fat right triangle down there. Okay, so I've got this right triangle. Now it just looks bad. Okay, there we go. We got a right triangle here where this is my x, this is my y, and this is my hypotenuse, okay? Now what's cool about this is the hypotenuse, we just said, or the radius, this looks like the radius of the circle. This is the unit circle, and we know that that radius is 1 because that's the definition of a unit circle. So I can label this as 1, and my goal is to find out what is this x and what is this y. Now, 30 degrees is really this inside angle right here. I know I wrote it on the outside, but you know, it's the angle, so it goes on the inside. And you learned in geometry about something called a special right triangle. Do you remember those? And so with a special right triangle, I'm just kind of clearing out some of my stuff here. There we go. On a special right triangle, you learned about 30, 60, 90s and the relationship. So on a 30, 60, 90, which is what we're staring at here, you have a short side that you could just call S. You have the hypotenuse, which is double that short side, and then this is S root 3. So if we take this relationship and look at our picture here, then what part of this picture do we know? Well, we know the hypotenuse is 1. So what I'm going to do is say, oh, okay, well, I know that 2S is 1. Because I'm staring at it in the picture above. So I would just solve for S. So if 2S equals 1, then what does S equal? Well, S would equal 1/2. That's just dividing off that 2 there, right? Or just mental mathing it. And so if S is 1/2, then the long leg down here is 1/2 times the square root of 3. And 1/2 times the square root of 3 can be written as root 3 over 2. So that just got me the lengths of all 3 sides of this picture, and furthermore, it just got me this point, because this point is the x, or the long leg, comma, the y, which is the short leg. Okay, so the coordinate that goes up here, if we zoom back down, now all my cool picture stuff is gone, dang it. Okay, so there was a line there was a circle going around here, there we go. So now we know this coordinate right here is the coordinate square root of 3 over 2, comma, 1/2. Alright, I'm going to skip the 45 one for now, because if you look up here, this is a measure of 60, right? Well, gang, if I did the same thing and this I drew from here to here, if I made a right triangle out of this and I dropped this down, this is also, like, this is 60, so this is also a 30, 60, 90 triangle. So I don't want to redo all the math I just did again, because it's this triangle here. It's this triangle again, except it's flipped up on its side. So what does that mean about this coordinate right here? Well, it means the lengths of the sides are all still the same. This is still a 1. It's just that now the short side is here and the long side is here. So it just means I need to take this coordinate that I just did and it flips. The x becomes y and the y becomes x because the long leg became the short leg and the short leg became the long leg. So it just switches those distances for x and y. So now I have 4 of the 5 coordinates. This we got at the beginning, this one we got at the beginning. We just figured out these two. Now let's see if we can figure out what happens at 45. Now we should be able to, and this should answer the question, why are they making us memorize the 30s and the 45s? Well, from geometry, the 30s and the 45s were the only special triangles that we learned about. And the reason for that is because they are actually the only special triangles out there, okay? There is no special 15, 75, 90 triangle. Like, that doesn't exist. But with a 45, 45, 90, people are usually better at remembering this one. You've got a side, and this one is side root 2. So old geometry stuff here. Now, which part of this triangle do we know? Well, if we look at our picture, once again, we still know the radius. The radius is 1. Where's the radius down here? Well, it's the hypotenuse, right? So I'm going to set this s root 2 equal to 1. Now I need to solve for s. So how do I solve for s? Well, I divide by the square root of 2. So 1 over the square root of 2 could go right here. Now I'm not going to stop there because y'all learned some point along the way that this is an ugly way to write an answer and you want to rationalize this answer. So instead of leaving a root 2 in the denominator, let me rationalize by multiplying by root 2 over root 2. Top times top, bottom times bottom. So we're going to write it as the square root of 2 over 2, which means this is the same thing because in a 45, 45, 90, the legs are the same. So when I go to write my x and my y, I just have to write that point, square root of 2 over 2, comma, square root of 2 over 2. All right, cool. So now you have seen how to construct the circle and where everything comes from. And, you know, some people may not care where it comes from, but for some people you need to see this so that it makes sense to you, so that you see how the world ties together and makes sense, okay? So now you have it. You're gonna have to do this for the whole rest of the circle, and don't get overwhelmed because there's a lot of sorcery involved and trickery, and it's pretty dang easy. So feel free to watch another video if you like over memorizing the unit circle and filling it all out.